while the Manhattan Project was being worked on, there was a science fiction writer who posted a story that completely they sent the FBI to his house because he had so many. He posted a story he published a story and they put it in a magazine, and it was like almost word for word how to build a nuclear bomb, and he had no, like, while they were working on the Manhattan Project, they were like, they took him and they were like, how did you know this? How did you get access to this information? He's like, what are you talking about?
This is the beginning of the podcast. Welcome back to another episode. Today we have Adam Knight and his two companions over here.
I have a name. It's Julian Taylor.
And Isaac Martin and
Julian Taylor. Jordan.
Oh yeah, Julian.
The third.
And Abdullah. And today we're going to be talking about some random science things because these guys are huge physics nerds.
I love Star Wars.
Hey man,
Pretty much.
we're pretty cool.
I know what a Klondike bottle is.
Klondike
A
bottle.
Klondike bottle?
It's an ice cream shaped bottle. No, it's called a Klein bottle.
You know, you didn't have to instantly insult us by calling us nerds, man. You know, we're pretty cool.
I mean, nerds are cool.
That's
we're
so true.
all wearing glasses. We're a bunch of nerds.
Yeah.
Or your glasses.
Tyson, do you take them off? Try to seem cool.
All
Okay,
right, how do you
so
wanna kick this off?
okay, Adam, you can start off.
Oh, I can start off. Oh boy.
Why? Because he's white.
All right. Well, first I wanna start by talking a little bit about just I don't know if your viewers are uninformed or whatever, but it's pretty big. The James Webb Telescope recently put out its first few images from deep space. So cool. Have you all taken a look at those?
Yes.
Actually, haven't.
They're gorgeous. They're incredibly clear. There are some great side-by-side ones of different nebulas from the Hubble's perspective and the James Webb Telescope. So the James Webb Telescope is a bit more deep space, and it has been in development for like 20 or 30 years. They finally put it up. I think there were 392 points of failure that could have occurred, and none of them did. So it was this great launch. Everything was set up, and they finally started getting pictures back, and boy, they are so clear and beautiful. There's this one of like this sky of like, it looks like dots, but when you zoom in, it's full spiral galaxies.
Oh wow.
Yeah, just then they just pointed it into black space, and that's what they found. So yeah, it can see. So the estimated lifespan of the universe is 13.8 billion years. It can see 13 billion years. So we're about 800 million away from seeing into look at those. Yeah.
This is the first one, right? Isn't there a second one following the same trajectory?
A telescope?
Yeah.
I don't know. All I know is that there are that one right there. Each of those is a spiral galaxy. Except for the ones with lines, those are stars.
Those are awesome ones.
Yeah. So this telescope is super cool. It's my big science fact or my big science like thing right now. And companies are and different organizations have been issued time on it. So they all want to look at different things, and so we should be seeing some more stuff in the future. But yeah, they're absolutely gorgeous. So going and looking at those, yeah.
So like, was there a point of it, or did they just say, hey, let's make a new telescope, throw it out into space?
It's exploration.
Yeah, space exploration. They want to see, because like the Hubble telescope had its limitations and like it wasn't as clear. And I mean, to be fair, the Hubble telescope lasted so much longer than it was supposed to. In fact, this one will too. Is estimated to only last 10 years, but because the launch was so successful, I think its lifespan has been increased to 20, which is awesome. Yeah. So, and yeah, the whole point of it is just to take clear pictures and just see what our universe is up to, see what's out there. And the big goal of it was to look into the center of the universe, to locate it, pinpoint it, and look right into the start of the universe. But because of that last 800 million, I mean, we can still probably get pretty close, but it'd be really cool to see the future telescope development and hopefully be able to pinpoint that start. Because if possible, we could completely, we could throw the Big Bang out, like we could prove the Big Bang, which would be cool, and be able to see how stuff started. So yeah.
Wouldn't it get exponentially harder to see?
Mhm.
Okay.
But I mean, this one is the James Webb is exponentially better than the Hubble Space Telescope.
Yeah.
So give it another 30 years and another telescope, and hey, I mean, you never know. Yeah.
But wouldn't it kind of be difficult to pinpoint exactly where where the universe originated from, since we actually can't, from our perspective right now, see where it all came from?
Yeah, it would be. And but so when you
There
The
should
what-
be a mass cluster, right?
yeah, and the way that you have to kind of think about it too is that while it is hard to pinpoint it, if you look back far enough, like if you look past 13.8 billion years, you will eventually see
Trajectories.
yeah, something like or nothing, which could lead to a sign. Because like I said, that one of those that big cluster of spiral galaxies, that was just them putting into black space. So if they did that and there was nothing, now we know, hey, we can look around and maybe try to find that particle that started everything.
That's pretty cool.
It's pretty
So you
neat.
think, are you a stagnant universe or a Big Bang universe?
Oh man, I personally like to think that it's a Big Bang universe because I like to think that it's constantly expanding, and I wouldn't know any other way that the universe could be constantly expanding like that and everything be moving without something that pushed everything out.
Also, isn't like static on old TVs a result of the Big Bang? Like it's picking up like old radiation.
But that's the thing. It's theorized that
I know.
happens.
But like, isn't gravity theorized technically? Like it's not fully proven.
Yeah, it's a theory of
Yeah.
gravity
Yeah.
because the mechanism isn't fully known. There's also Einsteinian like space-time where you fall into things, but
Yeah.
you don't move at all.
But I mean, it's pretty easy to show that there is some sort of gravitational effect because something comes up and it comes back down. You can actually prove that. You can't prove that something came out of nothing and that where the universe came from.
Yeah.
Until now, stick around for the James Webb.
Yeah, I personally think it would be I don't have a leaning either way towards the stagnant or Big Bang, but I think it's a fun idea to think of the heat death of the universe
fun.
collapsing into a singularity, and then the singularity restarting and exploding into a new Big Bang.
Oh, so it's like it's a vicious cycle. Oh,
Yeah.
The Big Bang and the Big Crunch. Yeah.
The
Yeah.
big crunch.
It's the wait, that's called like the big bounce. That's what it's called. This guy like
Oh.
goes in and out, continues doing that.
And the
That'd be
whole
cool because that shows a natural exponentially growing cycle, because if it shoots it out like that and keeps getting bigger, you keep building up energy and you could get so many cool things. Wow. That's crazy. I know that's neat. I like that.
imagine humans before the Big Bang.
We'd have 3 arms and 2 eyes.
And be made of antimatter.
yeah.
That would be
We'd be
cool.
like we'd be like Alien X from Ben 10.
I have a question. Isn't antimatter a matter of perspective though? Like, what makes it antimatter? Like,
It's
if there
actually
antimatter in the universe, wouldn't it just be matter, and then matter would be antimatter? Like,
Yeah.
Isn't that just a label?
Yeah.
yeah.
That one?
Yeah.
But
It
because,
travels
like-
backwards in time.
Yeah.
Yeah. So, and like the big theory with antimatter is everyone's like, the universe can only go so far. But what it's theorized is that around the edge of the universe, you have antimatter that's creating new stuff.
Okay.
Yeah.
Ooh.
And there are big facilities built way deep underground to find this one type of particle. And it's just a random chance that they'll be able to see it. But if they can capture enough of that particle, they'd be able to theoretically create antimatter, which could lead to making matter, or perhaps a black hole. But if there's a black hole on Earth,
It'll
I mean-
like-
Matthew McConaughey will be fine.
it'll likely evaporate.
Yeah.
before-
If you have antimatter the size of a quarter and you throw a quarter into it, would you just purely make nothing? Because I know like energy always transfers and translates.
So
Like-
if you get like a piece of antimatter and throw it out into matter, it'll just explode.
Yeah.
They've actually made some.
Will the energy just be gone, or would
It releases massive amounts of energy because
Yeah.
matter is E equals mc squared, so energy is equal to mass.
Mhm.
So the mass will be converted into energy when the antimatter and matter combine.
Okay.
And it's not that that energy will be gone; it'll just be dispersed into a large explosion that could rock the Earth.
And people are trying to make a spaceship out of that so they
Yeah,
can exit the
antimatter
Earth.
rockets.
That'd be so
Yeah.
cool.
But
we
it's,
have to figure out ion thrusters first. Though.
yeah, it's really hard. We have figured out ion
I'm a
thrusters.
fan of the warp
In a big-
bubble.
in a
Yeah,
from Star
so
Trek.
so for antimatter,
Did you just hear that?
for antimatter rockets, the problem is storing the antimatter because when it comes into contact with matter, it explodes.
So you have to make them out of antimatter.
So you have to
Put them in a vacuum.
probably store it in like a
Nice.
vacuum with energy, like magnetic something. I don't know.
And
And
They
what
actually-
better way to
they're
store
doing that
things
right
in a
now.
vacuum than with the best vacuum? This episode of the podcast is sponsored by Dyson Vacuum.
And then, so for ion thrusters, the way that works is the most popular ion thruster that I'm aware of is xenon.
yeah.
So it's a noble gas, and it is spit out the back, and it's attracted to an electron as well.
Yeah.
And so every single ion, the xenon is one of the heaviest noble gases, if not the heaviest. So you slowly accelerate.
So my question is, is that on a small scale or do they have large scale ion thrusters already?
Well, it's not really possible to have
Like,
large scale. It's just possible to have a lot of them.
Right. Okay.
Going back to the antimatter thing, they actually are. There's major facilities. I think SpaceX is one of them, and they're actually using magnetic containers to keep antimatter particles away from matter. And that's
Yeah,
how they.
It's those big like Epcot looking ball, like golf balls looking things in the ground. Yeah. They keep it so far underground and like I think there's got to be some sort of there's some sort of something on YouTube that I saw where it's like showing inside the facility and they have to like completely like disinfect themselves and they have to be because nothing can come in contact with anything in there. They have so many forms of security. It's impressive. It's very impressive.
I think it takes like just $1 billion to make 1 gram, which is like the most expensive material on Earth.
Yeah.
Is this it?
It's loaded through.
Yeah. Yeah. With those with all those mirrors.
That's Fantastic Four.
No, it's actually that giant space bridge. That's it.
Guys, you know what a warp field is?
Oh, that's Boeing. Wait, is that a spaceship? What is that?
I have
Oh,
no
Boeing
idea.
has space
I didn't know
flight.
SpaceX was doing antimatter stuff. I'm not aware that that's.
They're doing everything right now. They're trying to like be the first to do everything.
Cool.
Yeah, I mean, we're in a space race with just different businesses now.
Yeah.
Yeah, it is a spacecraft.
Yeah, that's a spacecraft. That's not the antimatter thing. That's cool though. I didn't know Boeing was trying to start a Starliner. That's kind of rad. I thought that they were sticking to military stuff.
Cool.
Wow.
Have you ever heard of a Dyson sphere?
I know what a Dyson sphere is.
Shut up. No, you don't.
That's what I want to work to make, or a Dyson swarm is what I want to work to make.
Oh, boo. It's not a Dyson sphere. What a loser.
Dyson sphere encapsulates a star. There's no way we'd be able to do that.
No, that attitude.
Not with any attitude.
Have
Called
you
asteroid mining, Adam.
Yeah.
Just mine out Mercury. That's my plan. Or
have
Venus.
you ever heard of the WOW space signal?
No, but that sounds
The
wow.
what space signal?
WOW space signal.
No.
Just WOW?
World of
Yeah.
I
Let me
haven't.
look it up.
That's in Star Trek.
I saw Wild Space Goat.
So basically, people were listening into hydrogen signals in the I think 70s, and then they got this weird signal that just blimped for a little bit, and that was the only time it ever happened. They went there the next day, a couple of weeks, a couple of months, never came back. So people are saying this is probably either aliens trying to give us contact, because hydrogen is the most common element in the universe. They might have made some space signal out of hydrogen. When other people say it's probably just the comet that became too close to the sun and hydrogen bursts exploding.
Yeah,
I
it
think it
could
was the second
definitely
one.
be either. But I mean,
You know the like monkey who
Yeah,
writes
yeah, the-
endlessly.
and like
Yeah.
eventually they have to type the
Yeah.
infinite monkey theorem.
And like
yeah.
WoW, WOW, that's kind of simple. If it was like, 'cause
Oh no,
you-
the guy was just wrote wow.
Oh,
We don't know what it means.
It's just a certain type of signal. It didn't send out.
I thought they translated it and said WoW.
But I mean, it's not completely out of the question that it could be aliens because I mean,
Yeah.
we've been guilty of it too, just sending out random stuff to try to make contact. Like what it was like a Rubik's cube and a recording of like Marilyn Monroe
No, and a lightsaber.
and a lightsaber.
Yeah, Luke Skywalker's original lightsaber from I think Revenge of the Snow. Wait, I know. I don't know what defines original lightsaber. I don't know if it's Anakin's or is Luke's, but his original lightsaber got shot into space.
Yeah, but I mean, and like we've done a lot of that to try to just like make
The
some
golden
form of
record.
content. Yeah, yeah,
Mhm.
that's the like some of the best music, just trying to show culture. And
Actually-
this is a really this is just another like a bit more advanced way of doing it than just putting a bunch of junk into a into a rocket and launching it out of orbit.
Do you
That's
know
pretty neat.
William Shatner, who plays Captain Kirk, also became the oldest man to go in space?
Oh yeah, he did that recently. Right?
Yeah,
He went on the
I think
Blue Origin
last
stuff.
year.
Man,
He's like a 90-year-old man. He went to space, and he's Captain Kirk from Star Trek, guys. It's so cool. I was Star Trek, man. Live long and prosper, my fellow dudes.
that's really cool. I haven't heard of that before. The wild signal.
Me neither. That's pretty interesting.
Yeah.
Now, you guys ever watched Interstellar, the most scientifically accurate movie ever made?
Oh my god, I hate that movie so much.
He
I think
made
I-
a whole bunch of discoveries with that one.
Yeah, it's good, but
The power of love, Marv.
it's love, Murph.
Marv.
Murph, don't let me leave, Murph. Shut up. Like, oh my god.
Hey, the power of love got him out of that asteroid.
That was a black hole.
It was-
Black hole.
It was honestly kind of boring in my opinion.
No, you're kind of boring, Omar.
It was like
There's a
it was
copy
like
and
a-
paste version of
I
your
thought it
brother.
was very interesting.
It was a good movie, but it's just like, yeah.
Yep.
Wow, ouch. It was a good movie. It was just like there were certain aspects where it failed. It fell short, like where they said that the power of love controls the universe, and we're not even going to talk about the paradox that he had to jump into a black hole and do all of that to put himself there. But
But
What
is
if
a
he
black
didn't
hole
go
outside of
there?
time though? He's inside the black hole.
they ignored the paradox. Okay.
There's no paradox.
I mean,
And then-
did you guys hear that to make the black hole they had to get a whole bunch of scientists over and they're the
Yeah.
ones that gave their calculations and stuff they put inside this new software and then
It's
Yeah,
beautifully
that's why it's one
rendered.
of those big. It was a really nice render at the time. It's still a great render to look at. I think Stephen Hawking helped out too because
He didn't.
he didn't.
but they thought that the halo was a mistake. So whenever they the animators brought it back to the scientists, they found out, oh, there's actually halos around the black holes.
Yeah.
Yeah, and
Event Horizon?
one of the
Event Halo?
interesting things about
It's
it
the light
that
thing.
they had to change a couple things for the artistic side of it. One of the interesting things that they changed was the side that approaches you is going to be blue shifted, and the side receding from you is going to be red shifted. So it actually looks like a different colors. So there's a gradient.
Really?
Uh,
I didn't
as
notice
it
that.
goes across. No, not in the original movie. In the renders, the original renders.
But then they removed it?
Yeah, so they just made it like a white yellow for the movie.
It was still impressive, but it was just
Yeah.
like it's cool that they originally had that kind of like thing.
Yeah, there were a couple different things that they changed for the cinematicness of the movie.
All I'm saying is, I think it's funny that The Martian came out like a year prior and reused 3 of the same actors. Like, you got Matt Damon trapped on a planet. You have Jessica Chastain. There's one other one. There's one other person new. from The Martian. There's the third one, right?
I think I know that there was. I
Hmm,
can't
I don't know, but Matt
Russell
Damon,
Crowe.
Russell Crowe. Now I gotta Google it. It's fine.
Yeah, no, it's a good movie. It's definitely there is a lot of good science in it. I prefer reading science fiction books. Andy Weir's really good at it. He's the guy who wrote The Martian. Recently, well, not recently, but he wrote. I read I think still my favorite book right now. It's called Project Hail Mary. That one's great.
No spoilers, please.
Wait. So what's Project Hail Mary about?
Are you serious? I said no spoilers.
Project Hail Mary is about it's about a micro little organism, and there are a whole bunch of them. They get labeled astrophage, and I'm not gonna like go too in depth because it's a great read. But basically, they're killing the sun.
Ruined forever.
They're absorbing energy from the sun,
Yeah,
and so
from the book
Earth
now.
is like drifting out and getting colder, and so like it's leading up to this apocalypse event. So there's a last ditch effort to launch a bunch of scientists into
You just ripped
It-
off
it-
Sunshine.
no into the Andromeda system to see if it's affecting other places, and if so, how they can like find a cure, basically find a way to cure the sun of these and rid them. And it's great. It's got great mystery elements, and like it's very science fiction. But Andy Weir's really good at knowing his facts as well, so he's able to make like science faction, which is just like and like it's so cool. It's great. It's a great read. Yeah, Project Hail Mary.
This movie called Sunshine, and Chris Evans and his motley crew go and reenact the sun.
You sure it's not what's it called? Buzz Lightyear?
No, what? Buzz Lightyear doesn't like the sun.
No,
He's-
you know,
he pulls it up.
space,
Did you not watch
space.
Lightyear?
Chris Evans.
Are you
both of
gonna
them.
define everything space with an astronaut as the same category?
No, but Lightyear did really good showing off relativity as well. Got to teach him young.
Yeah, the faster you go, the speed of light, the faster your friends die off.
Yeah.
So speaking of relativity, I had something that I was going to bring up is I was looking at the surface of the Earth, and so
No way, me
as you
too.
know, the Earth, as you may know, the Earth is not quite a sphere, but it bulges at the center,
No, it's
right?
here.
It's flat, actually.
So it's
It's a rectangle.
so that shape is called an oblate spheroid. And so I was looking up if the people who lived on the poles would experience time differently from people rotating around on the equator. But because of, so that would be general relativity. But because of special relativity, the people in the poles are slightly closer to the center of mass and the center of the gravity well. So the special relativity at sea level cancels out perfectly the rotational general relativity experienced. So actually at sea level all around the world, the time is felt the same way.
That's
Which is really interesting.
That's cool.
And also in Canada, they have the least amount of gravity, so you can jump 0.05 times higher than anyone else in the world.
Oh,
Let's
really?
go. That's where I'm going to train. Wait, no. I need to go somewhere with more gravity.
Why Canada?
because they've got
it's-
like they're one though.
Right there, it's
lumps.
like
They're like higher, I guess higher up. So there's less gravity over there. Gravity isn't like uniform on Earth.
yeah. I did an IA on that.
This guy did not.
Yeah, so actually the farthest point from the equator on the planet is Mount Chimborazo in Ecuador. So it's like 11,000 feet or 12,000 feet. So it's not that high. But because it's on the equator, it's the farthest distance from the center of the Earth. So technically, you should have the least amount of gravity on the peak of that mountain. And then if you add in like a solar eclipse, or no, a lunar eclipse, then you get even less gravity.
Jump so high. Yeah. No, yeah, it's very cool. I
I
love
can
it.
show you guys what it looks like quickly. So like around Canada up here, they've got less gravity than like where we're at.
Oh yeah, it's the Hudson Shield or whatever. This
Okay.
yeah.
And like it's like Gravity Falls but in Canada.
That's cool.
And basically like there's tons of anomalies all over the world. Some places have more gravity than others. Like in
Yeah,
Chile
I
they
know
have
there's anomalies.
more.
I've seen Thor: The Dark
I
World.
was thinking that too. Yeah, but some places people just lift trucks. Can you believe it? It's so cool.
So cool.
Have you guys heard of what's it called?
Yes.
Thank you. Photonic molecules.
Photonic molecules.
You mean
Yeah.
light photons?
Yeah, photon crystals.
Not crystals. They're like it's a step under it. It's like basically if you shine like a laser through rubidium cloud, you can actually make the light bond together, and there's like bonds.
Oh,
of
and like
2 or
levitated
3.
diamonds. Yeah, laser levitation or whatever it's called.
Yeah, something like that. But
It's
basically,
proving that
like,
light is a or color is a force, essentially.
Mhm.
Yeah, no, it's yeah, there's a good YouTube video on that. I think you showed me that for the first time because Isaac and I had this joke where we were in our physics class and I forgot like we were just talking about the different like types of forces like and I think Sam was the one that said yeah color is a force and then Isaac came to me the next day with a video of a laser levitating a diamond. And I was like, huh, color is a force. How about that? Like, well, who would have thought?
Have you guys ever seen what's it called? It's this thing, a thermoelectric cloud chamber. It allows you to see radiation from
Oh, yeah.
uranium.
Oh, yeah, yeah.
Yeah, like I don't know. That reminded me when you talk about your crystal particles.
So wait, what's a photon crystal?
So, light is made up of photons,
No.
and photons are the particle version of the electromagnetic field, because everything exists as both a wave and a particle,
Mhm.
and exhibits properties differently depending on certain factors.
Mm-hmm.
So a photon crystal is when you put those photons into a state where they exhibit more particle properties rather than wave properties, and they form structures.
That's crazy.
Basically, like solid light.
Mm-hmm.
How do I get my hands on one of these? Just from my collection.
Currently, you can't, and it's even if you actually, I don't know.
What if? Okay,
But
hear
even
me
if
out.
you could, it would be very unstable.
Scientifically, there's light all around me right now because of those. So what if I just clasp my hands together really hard? Wouldn't that condense the light to make me a cool crystal?
That is not
Ah,
how you get it to
good. Look. I'm just kidding, guys. It didn't work, surprisingly.
particle.
Oh, that sucks. But with light crystals and photonic molecules and stuff like that, you could actually create basically holograms, like hard light holograms, which is pretty cool.
Oh, that is kind of cool. Huh.
And they actually have created some types of holograms with little beads, kind of like how the old
Yeah, the
TVs.
styrofoam beads, and then they use
Yeah.
the speakers.
Oh, to make a picture. That's neat. How do
And
they
you can actually
control
feel it as well.
not like leaving, like falling out of the stream?
Omar, do you want to explain it?
I know you can explain it. I literally
Okay.
just watched a YouTube video 5 minutes ago. So.
Yeah, so they have an array of speakers that emit really, really high-pitched frequencies, and they converge in interference patterns to levitate the styrofoam molecule. And so the molecule falls into the negative part of the wave because it's a vacuum,
Mhm.
and then is pushed by the parts around it that are higher density. So it levitates in that area, and then the speaker's frequencies are changed, and so it levitates around super fast. So you can make like a circle, and then
Certain
it
picture.
has a light on the styrofoam bead, so it looks like it's an LED just floating in the
That's
air.
neat.
And they can even make like a butterfly or something. It was really cool.
All
And
right.
it
So
can,
how do
it
we?
can also make sound as well. So like
Hmm.
the hologram can talk to you.
Yeah, 'cause it has all those
Oh,
speakers.
that's so cool.
And I also, there was a really interesting paper I saw a couple months ago where someone was trying to get multiple beads into one array. So they were doing really
Oh.
complicated algorithms to get, they were working on the software to get those complicated algorithms to get those interference patterns workable for multiple beads
Were they able to do it?
in one array. Yeah, it was
Really?
really
How
interesting.
many did they get in?
I think I saw
5, right?
Okay. I don't remember. It was a while ago.
That's cool.
It's either
Basically-
5 or 3. It's a very small number, but they're starting to make more complex shapes and stuff.
Yeah. So basically, we need to get a couple of those and hook them up so that we can talk to each other like it's Star Wars. I see what you're saying.
Everything in
the-
Star Wars is coming together now.
Yeah, like the hacksmith, they made a lightsaber. Now all we
Oh
gotta
yeah,
use-
that was great. That plasma burning. I remember following that whole story, and when he finally dropped that video, we were in physics class, and I was like, Isaac, you got to see this. So cool. He sold that one too. And yeah, he's been building a lot of them. I think he made 2 of them for Mr. Beast. Like he's got the process completely down, and I can't
That's
wait
cool.
to see because I know that the Hacksmith is a really good YouTuber, and I can't wait to see what he keeps up doing because I know that he's going to keep trying to push it. Because like it started with like those proto sabers where it basically just heated up a piece of rebar, and then he was like, okay, we need to upgrade from that. So he had a titanium sleeve around, I think, an aluminum rod. or
Wasn't
iron.
it tungsten? I thought it was tungsten.
Oh
Yeah.
no, it was tungsten. That's right. It was a tungsten. Yeah, and then
And we were talking about lightsabers.
oh yeah. So yeah, I don't know. I think that he's gonna keep doing great stuff. And I mean, I love the whole YouTube science scene. Like Michael Reeves, sufficiently advanced Alan Pan. He's really cool. William Osman. He's so cool. Backyard scientist. Niall Red. Have y'all watched Niall Red videos?
I don't think so.
They're so like fun to watch. Like he just does these really weird chemistry things. Like he turned, I think, like vinyl gloves into grape flavoring. Yeah.
Wait, was he the same guy that made cotton into cotton candy?
Yeah.
Yeah, I've seen him.
No, so yeah, I mean the YouTube science scene is really cool, and I like those guys. I think they're all on like that Safety Third podcast. And I mean they're like that side. It would be so cool to be able to do that, but you have to get super lucky to make it on YouTube. Yeah. But yeah, I don't know. The Hacksmith is just another. I've been watching him since I think my first Hacksmith video that I watched was when he did the magnetic Captain America shield in like 2014.
Really?
Yeah, he put like the magnets on his arms and that was back in his old
Bulletproof metal.
warehouse. Yeah. And that was really cool. So it's just cool to see where he's come since then.
Yeah, I started watching with the Iron Man, Make It Real Iron Man
Yeah, I
costume.
remember that one.
Oh yeah, when he put like the CNC cutter into his arm, that was so cool.
I started watching whenever he made the Kylo Ren lightsaber.
That was yeah
Oh,
yeah
okay.
the Kylo Ren proto saber when he had the yeah, that was a good one. No, yeah, that seems cool. So I definitely think that he's going to be able to compact the lightsaber and be able to make upgrades and stuff, and maybe eventually be able to actually make it fit all into that handle. It's just going to take technological developments from the industry and then him utilizing them, which
Yeah.
he'll be able to do.
Making it more STEAM instead of STEM, putting the art part in the I don't know if you've heard that before, but instead of science, technology, engineering, and math, it's science, technology, engineering, arts, and math, because the science fiction and stuff is driving some of those other innovations by coming up with those crazy ideas
Yeah.
and then developing the technology to develop the technology to build some of that stuff, which is really cool.
Speaking of scientific stuff, have you heard of time crystals?
Time
Mhm.
what? Crystallized time? No.
It's the trippiest thing. I still don't fully understand it, but like from what I know, it's like a crystal that repeats itself over and
Yeah.
over.
Oh, it's got one of those patterns called when a pattern infinitely repeats itself.
But that's
What's-
that's
it's-
all I know about it.
I forgot what they're called. There's that one really famous one, where it looks like it kind of looks like a you like zoom. What's it called?
Are you
It's
talking about like the exponentially?
it's
zooming in?
someone's sequence. Wait, infinitely.
Dinger sequence.
Is it Attingers? Yeah, it's called this one. It is a fractal. It's called a fractal, and there's a certain
Yeah, so it's not quite a fractal. It's more like those like chemistry reactions where they like revert back and forth. It's something like that, but the solid state is a repeating pattern, sort of. I don't completely understand it either.
It's really confusing, honestly. But
So wait,
Oh.
what's the point of a time crystal? Yeah, then the Mandelbrot set is the really famous fractal. That's a cool one. So yeah, what is the point of a time crystal? What does it do? Like, do you put it into your time machine and it powers it, or
that's what I thought. But I think it's just a fancy crystal.
it's just a cool crystal?
No, I think you can use it for clocks and things like that.
Well, I would hope so. It's a time crystal.
Like instead of atomic clocks, measuring like electrons orbits, measuring repeating patterns. There were a couple other uses for it, but I don't remember. But yeah, it does have some practicality to it.
Maybe you can just use quartz like in Ben 10 and make those dimensional portals.
Yeah, no, I think that's yeah. We got to get the Omnitrix first.
Yes.
I mean,
Raising
first we
it
need to
and
find
people.
aliens.
Yeah.
Have you guys seen? Because like, if we don't have aliens, it would just be like. Have you seen the TV show Wildcrats?
Wildcrats?
Yeah,
They just transform to different animals with machines.
Oh, yeah, I have seen that one was on PBS, right?
Yeah.
Or it's kind of like the Unitrix.
Yeah.
but have you seen the original with Sabumafu?
Let's go, Zaboomafoo!
Zabumafu was a ring-tailed lemur, and the Wildcrats were like they worked with the lemur
Yeah.
in the
Yeah.
show.
So it was like half live action, half 2D cartoon.
Oh yes, yeah, I know what you're talking about. I didn't like the live action because they kind of look like old men, so I preferred like
Scary.
yeah, exactly.
PBS, oh man, PBS went so crazy. Word World, oh boy, let me tell you, when I wouldn't know how to spell today if I didn't watch Word World. Yeah, no. Let's see. Another cool one. One of my talking points that I kind of wanted to go over was, and I probably should have talked about it earlier when we were talking about gravitational anomalies, but white holes.
Yes.
I'm a personal believer in the white hole. I think that there are two. I think that it kind of goes with the idea that everything has its equal and opposite. Every action has its equal and opposite reaction.
Mhm.
So you have these.
Break it down.
Yeah, when you have on one side of the spectrum you have black holes, I think it's perfectly understandable that if that is kind of like a condensed like kind of anomaly in space time, that you can have the opposite of it. And maybe we'll be seeing one of those with the James Webb
Wait.
telescope.
Which means with white holes, there's also anti-gravity.
Yeah.
Yeah, it's instead of exponentially harder to leave a black hole, it's exponentially harder to enter the white hole.
Yeah.
Um,
Matthew.
They're actually trying to create anti-gravity right now, but I don't know how they can create it since there's no gravitons.
So how would anti-gravity work? Like it would just like kind of be a force that goes against gravity and then you can make things float, or would it be gravity in the other direction?
I
Yeah.
think
Gravity,
it'd
but
be
you
gravity.
go up.
Is it like quantum gravity or Newtonian or Einstein? What is the
Newtonian gravity. I think.
Newtonian?
Yeah, I think they're trying to do a Newtonian gravity because they're trying to make people float, like
Okay.
helium.
So they're just trying to kind of make a something that could emit a force that would negate the effect of gravity on someone.
Yeah, pretty much.
Okay, that's
Kind of like
Be
how
like a thing.
Superman just floats.
yeah, yeah. Well, Superman actually has a gravitational field around him that he can control. So I
Right.
guess that's why he's able. That's all,
I
like
think
why
he canonically manipulates graviton.
Yeah, because that's why Man of Steel shows it really well when he goes in for his first flight. He like puts his fist on the ground and you see like the rocks sort of floating as well because he's kind of manipulating.
Oh, I did not know that.
Superman's a
bloody
living
float.
plant.
I don't know about the field.
I'm pretty sure he like that's kind of like the Kryptonian field or something of sorts. I could be wrong. I'm sorry, comic book fans, if I'm just dead wrong, but that was my understanding of it, which is pretty neat. Because like,
No. Oh, you can continue.
no, you go ahead.
Inside a black hole, if you go inside the singularity, it's kind of like a time
Lots of
singularity.
books.
Wait, what do you say?
I
Not a
said there's lots
bookshelf.
of books.
It's not lots of books. You're not behind Matthew McConaughey's book. What did you say that there was inside
Sorry.
the singularity?
Inside, if you go inside a black hole, it's a time singularity. So you can never actually escape the time singularity. And if you try to escape it, you go further inside of it until whenever you enter the singularity, your atoms will infinitely shrink forever.
Yeah, spaghettification. I actually spaghettification happens on like the event horizon. I just don't think it's possible to go into a black hole. It's just too dense. Humans weren't built that tough.
Yeah.
If
Do
you
you
go
think-
inside of the neutron star,
A neutron
all of your neutrons will be ripped out of your body. And
What a nice and painful way to go.
Yeah,
Just being
and-
turned into galactic mush.
Yeah, and the electrons collapse into the
Into the electron field. I mean, your
Protons.
atoms essentially just fall apart.
yeah,
Yeah.
You explode though. If your neutrons are ripped out, you just become like super positive, right? You'd be a happier person.
Oh my god.
I'm pretty sure that's how that works. Yeah.
There was a really good bit on, I think it was Mad, but it was just like this one-off like little thing. It was like black hole bungee jumping, and it was this guy who like he's like this astronaut. He ties a bungee cord around his waist and he jumps to a black hole. He just doesn't come back out. So funny.
So speaking of neutron stars and black holes, there was another paper I read recently where it was talking about the mass gap. So the mass gap is one of 7 millennium problems, which were created by a university. And so they're math and science problems. Only one of them has been solved. And they have a prize of like $1 million.
So here on this podcast, we'll be solving a second millennium problem. Which one got solved?
It was a math one. I don't remember which it was. But the paper I read was talking about the mass gap. And it was talking specifically about neutron stars and the fact that if you had a neutron star spinning fast enough, like those exoplanets that spin super fast and form a disk shape, you could have a neutron star that bulges more if it was spinning fast enough, and it could take pressure off of the core, so you could have a more massive neutron star.
Just what
But
we needed.
they were, it sounded in the paper like they were implying that that would solve the mass gap, that it would reduce the mass gap. But from what it sounds like to me, it seems like there should be, like we should expect a mass overlap,
Yeah.
because if the neutron stars are collapsing into black holes because of force on their cores, then we should expect the spinning ones to be more massive than the smallest black holes, which I thought was really interesting. So the mass gap is even more perplexing.
Yeah.
So there's no solving it.
Not yet.
Was the one that got solved, was that Fermat's last theorem? Fermat's Enigma.
I believe.
Yeah,
So.
it was that
Explain that?
Andy guy. I remember because there's a good book on that called Fermat's Enigma.
Yeah. So there were two different groups. One of them was a bunch of different mathematicians.
Yeah,
Um,
Pierre de Fermat was he was a real guru. That guy. I mean,
Yeah.
he was I think he was a 16th century mathematician. He was actually not an official mathematician. He was an accountant, I think. And
I mean, the
he
same
did-
thing. They deal with that.
Yeah.
Oh, it was the Poincaré conjecture.
Okay. Well, but like he had this. He would basically he wasn't allowed into the math society, and so he would basically take their theorems and solve them, and then send them back to them. And they got super pissed at him, because he would just do this, and he'd be like, "Yeah, I solved this. You go ahead and do it, and then we can compare." And before he died, he was trying to solve the theorem that with Pythagorean, so a squared plus b squared equals c squared. So he brought that down to a to the x plus b to the x equals c to the x, and he was trying to prove that that wasn't true for anything if x did not equal 2, right? Or if x was greater than 2, I think. And he allegedly solved it, but he died before he could publish. He was basically like, I solved this. He burned the evidence and he died. And so
Why?
like, yeah, exactly. And so it was just out of spite because he didn't want he wanted them to prove it. He didn't want to like leave it behind. And so I think it was pretty recently that someone was actually able to sit down and solve it. And he finished off and he was just like, I think the words that he said, that the dude who solved it, where he was like, I think we can all see where this is going. Like, I'll just leave it off there. And then there was just like a bunch of like clapping. But he like filled out a bunch of chalkboards with just math.
That's cool.
It's interesting to watch.
That reminds me of like in ancient Greece, I believe, like
Are you
Archimedean
talking about the Pythagorean Society?
times, they did basically math battles.
Yes, I know that.
So they would hold on to their solutions to these problems because they would challenge other mathematicians to solve their problems.
Yeah.
And if they won, I don't remember.
I think they would. The other one would lose their math title, and they have to like
Yeah.
renounce everything.
Yeah, I know, like, oh man, math used to be so cool. So also in ancient Greece, during Pythagorean, when he was alive, he created this society that lasted a while. It was called the Pythagorean Brotherhood. And they were they basically got together and they solved math, right? You had to let go of all other possessions, and you weren't allowed to tell anybody about what was found, like the findings in the Pythagorean Brotherhood meetings. And if you did spill the beans, they would stone you to death. Math used to be hardcore.
They
Oh,
still
wow.
did that in medieval times as well.
Yeah. I mean, it was a lot easier to get stoned to death back then. You could basically you could do the equivalent of like what is jaywalking today and get stoned to death.
Have a word on your nose.
Yeah, be a woman. Like, it was just a simpler time.
With those math battles, have you heard of the cubic formula?
The cubic formula.
Like quadratic formula.
Was for cubic functions. Yeah, exactly.
X is negative b plus or
I
minus.
used to have it on me,
4c all over 2a.
Yeah, it's so long. It's ridiculous.
but
and
Like
there's-
three-dimensional objects. That sucks.
it was originally it was like very, no one knew about it because like you said, they wanted to keep it a secret just for them. But one of the guys proteges apparently just spilled the beans, and the guy got so angry he went and killed him. And then there was like a murder, like mass murder. They were killing each other. Each family was killing the other one. It was crazy.
All right, here. I'll read it out here. I have it.
Please don't.
The cubic formula is x is equal to the cube root of negative b cubed over 27a cubed plus bc over 6a squared minus d over 2a plus the square root of negative b cubed over 27a cubed plus bc over 6a squared minus d over 2a squared plus c over 3a minus b squared over 9a squared cubed. All that plus the cube root of negative b cubed over 27a cubed plus bc over 6a squared minus d over 2a minus, it's just the same thing repeated, I guess. And then all that minus b over 3a. Huh. Wow. I can't wait to not use that ever. That'll be great.
Math teachers in middle school 50 years from now, you have to
Yeah, they'd
memorize
be
this.
teaching that. All right, kids, let's all sing this song. X is equal to cube root of negative b over.
Dude, that would be a pain.
Yeah.
Like, I got a question for you guys.
Yeah.
So this is gonna jump to time travel, but if you were to press this button and you can time travel anywhere you want, but the
No.
first thing you have to do is kill your grandparents.
Oh, are we talking about the grandfather theorem?
Yeah.
Paradox,
Okay.
yeah.
Or the grandfather paradox or whatever it is. What is it like? Would I do that? Or like what would happen? Or
Would you click the button so you can time travel?
No, I don't want to time travel.
maybe. Why not? Scared?
Yeah.
Yeah, that's fair.
I think it would be interesting though if we could send information through antimatter.
Backwards in time.
Yeah, like
You'd
find a
need
way
good receiver,
to
though. You'd have to build the receiver
have it
first.
decay. Yeah.
Do you know
Have
that-
it decay at a certain point, which is when it's created, sort of, but it's decaying because it's backwards in time.
Do you hear about do y'all know about Stephen Hawking's time travelers party?
Yeah.
Yeah.
And no one
that's
showed
upsetting.
up.
I wish someone had showed up.
I mean, what if they just didn't want to create a paradox?
That's what I'm saying. They didn't want to let him know.
Then they just all show up to his I mean, this kind of sounds bad, but like they all show up to his deathbed and say, you were right.
You were right, man. And that's what's really upsetting to me about his death too, is that he worked his entire life trying to prove black holes to be true. And when we finally got a picture of one, he was dead. He died like months, I think actually like weeks before it. It was just it hit me.
That-
Yeah. Yeah.
Sucks.
That first picture in 2017, he died before.
Yeah, and we've gotten a couple since then as well.
Oh yeah, I mean, we know about them now. But yeah,
You
that's
guys-
another good movie. Is The Theory of Everything. It talks about it's the life of Stephen Hawking. That's a good one. It's got Eddie Redmayne in it. He played Newt Scamander.
Do you guys believe that teleportation is gonna be a thing?
I think it's possible. It would probably be done using currently available technology, like doing it atom by atom deconstruction thing,
And moving it.
and then sending that information through either photons or maybe even like entangled particles
I know that like
to another location, and then rebuilding that atom by atom.
I think the most
atom by
accurate
atom.
one or the most interesting one to me is what's it called? Is the way they do warping in Star or beaming in Star Trek, which
Mhm.
is basically the person. It makes a clone, and then the consciousness is put into the clone. So basically, the person dies and they get reassembled.
Well, that's kind of what I was talking about as
Yeah,
well.
but the thing is, you'd have to know how to store information from the brain to be able to translate that, and I don't think that's plausible right now.
Mm-hmm. I mean, right now they did take pictures of quantum entanglement, so like we're a step there. But like
yeah, dude.
having
sorry.
like a machine store your consciousness while the assembly is going on, I don't think we have the storage space for that yet.
There's a project called you've probably heard of like the Human Genome Project,
Yes. Yeah.
where they were encoding the human genome, every single protein, nucleic acid. I mean,
That's insane.
and so they finished that, and they've been studying it ever since.
That's really
they've
cool.
done it a couple times. But there's another project that I think is really cool called the Connectome Mapping Project. And so what the Connectome is it's a map of every single neural connection in the brain.
Dude, that's
So
cool.
that would lead into artificial brains being able to be made.
Yeah. So like
Yeah.
upload that show where they fry your brain and put you in the afterlife or whatever. Like that would theoretically be possible.
Oh, what,
if
like
you
Black
could-
Mirror?
Yeah.
Yeah.
I mean, then they do that to like what's his name, Vision, in in Infinity War. You know, whenever they're doing all this neural connections and sending it away from
Yeah.
Oh
Mind
yeah,
Stone.
yeah. Yeah, they were trying to sever all that.
Yeah, well, they've actually succeeded with the world's smallest brain. It's a worm that has 3,000 neurons.
Yeah. It's actually
and
Isaac's
so
brain.
it
It's
was-
so tiny that they got the world record.
So it was a simulated worm, and so it wiggled around and stuff.
A simulated worm.
Yeah.
So they made some form of intelligence.
I think they hooked up the brain to I can't remember if it was a simulation or if it was
like a biological.
they hooked up the brain to the like body of a dead worm or something like
That's
that.
crazy.
It would be cool if they put it inside like a 3D printed worm, because then you know,
3D printed worm, carbon printing.
artificial like
Meat.
beings. Yeah, yeah, pretty much.
Just a nice T-bone that starts wiggling around.
Well, we're working on those artificial kidneys and hearts and stuff. Why not make a worm out of it?
I mean, it's simple. So
That's funny.
Biology, we had to learn about the neural stuff, and it was so annoying because you had to learn about the human body, and then you had to take that and put it inside animals and see everything about animals.
And the brain is just so complex. That's why it's just. I think that's why. I don't know. It's such a complex organ, and I think that we're just too many years away from truly like understanding it and all that.
I think they've actually succeeded in doing like a cubic millimeter of a human brain.
Yeah, and that's so
Um,
small. Actually, that's pretty
but-
significant.
Yeah,
It's small, but I mean, you think about the size of it.
there's like
Cubic
what
millimeter, what is that
trillions of
like?
neurons.
What is that like about? That's about like that big. not ginormous, but
Yeah.
have you guys heard of cold fusion?
cold fusion.
Mhm.
Basically, like they discovered an electron that's like I think 2,700 times denser than electrons. So like its orbit is way closer to the nucleus than what a regular electron would be. So two atoms with muons would basically like fuse together without any heat.
Dang. So you don't. That's weird. Does it still have the kind of like the energy output that fusion would have?
It's
Because there's
called
no heat.
exactly.
Whoa.
So it
Think
just
together.
lumped together.
It's like quantum Legos. That's crazy.
Yeah, I know. So like you could technically make not artificial suns, but basically you can like make steel and a whole bunch of other strong elements without, you know, heat. Or
Actually, like, yeah, it's alchemy in a certain sense, which is kind of cool. Or what would be perceived as alchemy. Using that, can it go enough into depth that you could change the type of element that you have? You
Yeah.
can put electrons into it, so you can turn like what magnesium into what's number 13? Oh, what's number 13? I know magnesium is number 12, but like you could take an atom or take an electron away or put one in.
yeah, basically.
whatever.
Because you know, you can just lump them together.
How fast can it happen? Like, could you change iron into gold if you had enough? Like, that's crazy. That's actually really cool.
The issue is that it takes a lot of
It completely messed up the gold standard, but
I mean, it'll still be pretty cool. Like, I mean, it wouldn't really destroy anything that badly because look at silver. No one uses it, and our economy's still
yeah.
okay.
So you'd be able to use it for more efficient and
Exactly. Yeah.
things, which would be pretty neat.
Only-
Like that's cool because I mean that's literally like what people. I've been waiting for something like that to happen, to be able to artificially restructure an element or an atom and turn it into a whole different element, because that's just like you have a certain amount of control over something. That's
Yeah.
really cool.
Well, I think it's an interesting idea to think of. Every time we discover a neutron star, we're discovering a new element. And then every time we look at the neutron star again, it's a different element.
Really? What do you mean by that?
Because a neutron star basically exists as a giant nucleus.
Right.
And so it's constantly changing how many protons it has, because it's not all neutrons. There's some like variation in the surface and stuff like
Is it-
that.
So have you heard of neutronium? I think it's basically like element 0, which is just like a neutron.
Yeah.
Just a neutral particle.
That's it. I think it's like 2 neutrons fused together. That's a neutronium.
So is that what they use for cold fusion? If they're just pouring neutrons into something?
I mean, they want to use it. They
No.
want to use it for a cold fusion, but like, it's kind of like a mini neutron star.
Oh, you're right. Because that's cool. Have y'all heard of laser cooling?
No.
So I know about laser cooling. So laser cooling is, I mean, like, you know, it's another attempt into trying to bring a particle down to absolute zero. So I think right now the big thing is quantum cooling, which there's this really cool video that goes over a quantum cooling setup, and it's just like all these tubes, and it's really tough to understand. The laser cooling is a bit easier. So
Yeah. We were talking earlier about that hologram technology with the levitation.
Mhm.
It kind of uses the interference. Like
yeah,
that.
the same kind of way, because what laser cooling relies on is the Doppler effect. So when you
Mhm.
have a certain like I think it's usually used on electrons. So when you just have this particle, it's naturally going to try to go towards a certain frequency, right? So you shine it's easier to think about it in 2 dimensions. So if you have a laser, two lasers of the same like frequency pointed at it, it's going to start traveling towards one, but as it does that, this one's going to get shorter and this one's going to get longer. So it's going to try to go towards the one that it wants to be. And so that basically, it just kind of goes and shakes, and it gets slower and slower because it keeps changing because of the Doppler effect. But you can't get it down to absolute zero because there are some imperfections there. And so what I always thought, in the same way that I think white holes have that same sort of idea of, whoa, that was really loud. Sorry about that. They're listening to. Can you hear that in the background? They're listening to.
I couldn't hear anything.
Oh, hey, there you go. So in the same sense that I think that white holes exist for, like, you know, equal opposite kind of action. Every action has its equal and opposite reaction.
Mhm.
I think that there's something that you can perceive as the opposite sort of end of the spectrum of the Doppler effect, where instead of as you get closer to something, the frequency gets shorter, as you get closer to something, it gets longer, and then in the back it gets shorter. And I think if we can figure that out, then we would be able to actually laser cool something to absolute zero, because then it would be so much more efficient, because as it travels this way, this one gets longer or shorter, and it just but there's nothing there that I know of so far.
So what would absolute zero look like in the real world?
No one
It
knows.
would be basically time not existing.
Because it's just something literally not moving, which is weird to think of. There are some people who have theorized that it would create a black hole. I don't know how that would happen.
Yeah,
I don't think
know.
that's true, but that, you know,
I
that's
mean,
like
it
one
kind
of
of
the
would
counter
make
arguments. Like,
sense.
you can't get something to absolute zero; it'll make a black hole. Like, we're trying to make antimatter, okay? Just calm down.
Yeah, currently it's impossible to get something to absolute zero because
You would need a perfect
the
vacuum.
energy will like quantum tunnel into the thing, and like you need vacuums, and in the perfect vacuum there'll be energy leaking through that'll turn into different particles and stuff like that. because there's just fields coming from like gravitational fields, electromagnetic fields. You can't really put that down to zero.
We've gotten it very close, but it's just not close enough to be absolute zero.
Going back to what you're saying, I think it absolute zero would cause a black hole because like if it's stationary and doesn't move in time, wouldn't it make a rip in space time?
It could, but you also have to think about it as
What would cause that though?
it wouldn't. I don't think because I mean, would a single particle be able to do that? Because I mean, if it is truly stationary, like what I love thinking about, like the easiest way to picture how fast you're truly moving in space is like if you were to stand completely still, you just stood completely still exactly where you
lost
were.
all your inertia.
Yeah, just instantly, right? And let's say you're permeable too, so you don't get annihilated by an asteroid. If you stay completely still, like Earth would be gone. Like
No, I'm the center of the universe.
in the blink of an eye. Yeah, in the blink of an eye, you would be floating probably in a new, galaxy because that's just how fast. Like, because we're moving this way and that way because and that's not just in the solar system but in our galaxy as well, in our place in the
I mean,
universe.
if you assume that our universe has a center.
Yeah, so if you were just there for a second in the blink of an eye, space, just empty space, like, and Earth would be probably centuries ahead of you at that point because of relativity. I don't know, it's just an exercise. So I don't know if putting something at absolute zero would stagnate it in space time, but it would certainly be very cold. I can tell you that much.
Also, that's why time travel doesn't work.
What do you mean?
Because
Because you'd have to locate exactly where you would be in the future. Yeah, yeah. Which I mean, theoretically is possible, but you need a very smart, cool computer. Yeah.
I mean, unless you were doing it through information and
Well,
not
like,
reconstruction,
Come
kind of
back
like
to this tree.
we were talking about teleportation.
Yeah.
So you'd just go from something built in the present to something built in the future or something like that.
Yeah, I think it'd be more understandable to use like a wormhole to like fold space time. I think that because you could probably get the same effect, right? Well, actually, never mind, because wormholes are just used for traveling in space, not through time. You have to fold time, not space. And I don't know how you do that. Probably with magic. So let's invent magic, and then we'll be fine.
Sounds good. I'll get right on that.
Yeah, I don't think it could be that hard.
Have you guys heard of cool plasma? Cold plasma?
Yeah.
Cool plasma.
Yeah.
It's like plasma, but it wears shades and it's really cool. You invite it to your birthday party.
It doesn't require like the crazy high amounts of energy that normal plasma does.
Plus it freezes stuff. It can
Yeah.
freeze water.
Oh, that's cool. Dang. I gotta get my hands on that. Actually,
I forgot
can't.
how it works though.
I think you just hook up plasma to like a dry ice or something like that, and then it cools the atoms, but not the electrons. The
It
electrons
cools-
are still.
yeah,
You put plasma in a glass and then you add some ice to it and it turns into a different thing. It turns into cool plasma.
I don't know, something like that. I mean, you
That
can
ice.
find
Oh my
YouTube shorts on it.
Goodness gracious. That's cool.
One of the like 27 states of matter or whatever it is now.
Yeah, it's not like 5 states of matter. It's like, I don't know, 30 now or something like that.
Yeah, it's
Oh,
pretty nuts.
Back in my day, there were 3.
I wonder if they teach only 3 in school now.
They do. You still don't learn about plasma or Bose-Einstein. Like, they
Or-
should, but misinformation.
Yeah, I learned about it from Moby from
Oh, right, yeah.
Brain Pop. Yeah, the video kept playing because the teacher had left the room, and they talked about plasma and Bose-Einstein condensate. And I was like, "There's more than 3 states of matter," and she was like, That's a bit too advanced. And then we didn't talk about it at all until like,
We were in Mr. Crow's.
yeah, and we weren't even like supposed to be talking about that necessarily.
Mr. Crown was chill.
Well, we got 1 minute left, and I think we covered most of the scientific topics that we're supposed to cover.
Yeah,
Uh,
this is fun. I love talking science stuff.